Trigonometric ratios are the ratios of the sides of right triangles. If you consider a right triangle with theta as one of the acute angles as seen below, the trigonometric ratios are defined as follows. So if we have a right triangle, and we know it is because of the square here, and I'm going to say that theta is right here, I can label the sides of the triangle as opposite, which is on the other side of where theta is located, the opposite side, adjacent, which is exactly next to theta, and then hypotenuse, which is always the longest side of a right triangle. When we have a right triangle like this with opposite, adjacent, and hypotenuse, we can find the 6 trig values as so. Sine theta is opposite over hypotenuse, O over H. Cosine theta is adjacent over hypotenuse, A over H. Tangent theta is opposite over adjacent, O over A. Now the reciprocals are really easy. Cosecant theta is just sine, but with opposite and hypotenuse flipped. Secant theta is the same as cosine, except hypotenuse and adjacent are flipped. And cotangent is the same as tangent, except opposite and adjacent are flipped. An easy way to memorize these ratios is to use the mnemonic device SOHCAHTOA. Sine, opposite hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent. SOHCAHTOA is a nice easy way to remember instead of having to just memorize each one all on its own. And once you know what those 3 are, you can just do the reciprocal of each one to get the other 3 trig ratios. Now, since trig ratios use a right triangle, it is important that you know how to complete the sides of a right triangle if you are given only 2 of the sides. For this, we use the Pythagorean theorem, which is a squared plus b squared equals c squared. And you find a, b, and c from a right triangle like this. Now, a and b are interchangeable. Doesn't really make much of a difference which one's a and which one's b, as long as this is a or b and this is a or b. But c must always be the hypotenuse. There is no negotiation. C must be the hypotenuse. A and b are the opposite and adjacent sides, but they're interchangeable within the theorem itself.